Gururaj JP, Assistant Professor, Government First Grade College, Haryana. The subject which is I am covering is data structures using C, which is kept for second sem BSc Computer Science students of Unary University. Now I will explain the session 1, which covers the topic of structures and unions. Structures. Structures are used to represent a record. Suppose you want to keep track of your books in a library, you might want to track the following attributes about each book. In this case, the structure will help because the structure will consist of these things, that is title. Here I am showing the wanting title, authors, subject and book ID. As in functions, we should be declare structure before it should be used. That means structures are should be defined and declared before they have been used. There are three types of structures: tag structures, structure variables, type defined structures. Now I will begin one by structure definition. Structure in C is a user-defined data types that enables us to store the collection of different data type. That means in a single thing, we can combine all the different data types in a single name. Here, the data types may be anything. That is, it may be int, float, character, or anything. I will explain. Struct here, what I am pointing, this is the struct. It is a keyword which tells the compilers that a structure is being defined. Next, to adjacent, there is a structure tag. That is the tag name, is the name of the structure. Next, type 1, type 2, and so on. Here, these are the data types which can be used. Member definitions. These member 1, member 2 are called members of the structures. They are also called fields of the structures. The members are declared within the curly brace, that is opening here. After the tag there is an opening, and last in member definition there is a closing brace. In between it should be declared. The data type, as I told, it may be anything. Type 1 may be int, or type 2 may be character, type 3 may be float, or it may be all the combination of these things. The closing brace must be ends with semicolon. The structure tag is a optional and each member definition is normal variable definition such as int I or float f or any other valid variables. At the end of the structure definitions, before the final semicolon, you can specify one or more structure variable, but it is optional. As I told, there are three types. The second one will come under these things. Book is the variable name which is given to the structure. Next, declaring the structure variable. Struct student, opening brace, int age, character name, character, branch, struct, students. S, student is an tag name and S is the variable allocating. Structure initialization. Like a primary variable structure, variables also be initialized when they are declared. Structure templates can be defined locally or globally. If it is local, it can be used within that function. If you want to access outside the function, it should be declared globally. If it is global, it can be used by all other functions of the, and student is the type ID which I have been used. Next, we can initialize the structure member while defining the structure. Struct student int age equals to 20, character name 20, that is array type, equals Sona. Sona is the name which is I am allocating, and closing the brace, I am giving the variable as S1 and ending with the semicolon. This is an absolutely invalid. The above is an invalid. It can be declared as given below or as shown below. I am explaining struct student int age comma roll. Roll is the roll number. I am allocating character name 20, that is array characters, and closing brackets. Struct is an once again keyword. Student is the tag name, and S1 is the variable which is I am allocating to the students. Here I am initializing the values, 16 for age and 101 for roll number, and Sona is the name of the student. Similarly, for variable 2, 17 is the name and 102 is the 102 is the roll number, and Rupa is the name which is of a student. If initializer is less than number of the structure variables, automatically resets values are taken as 0. Accessing structure elements. Dot operators are used to access the structure elements. Its associately is from left to right. That is, it will begins always from left to right. Here structure variables s1 dot name. See, here s1 is the variable name dot name is the values. S1 dot roll number, S1 dot age. Here the dot operator is used. Elements of structures are stored in contiguous memory allocations. That means it is stored in a continuous memory. That means in a single. Values of a structures variable can be assigned to another structure variable of same type by using assignment operator, that is equal operators. Example, hash include header file, hash include conio.h, void main begins, int roll age character branch. Closing the main function, s1 and s2 are the variables. Print enter roll number, age, branch. Scanf, percentage d, percentage c. All these are control strings of a data types s1 dot roll, s1 dot age, s1 dot branch. Previously, as I have given the example, same thing I am accessing here. Here s2 equals roll number equals s1 dot roll number. Print the student details. Print the same. Before printing, I should mention the control strings of the data types, that is percentage d, and percentage c for character, roll number, age, and branch. Print s2, that is percentage d is a control string of s2 roll number. Unary relational arithmetic bitwise operators are not allowed within the structure variables. That is for from s of 0 to the s of 199. Puts s is the output statement used to print the data from s of 0 name to the s of 0 branch. All the data which have been entered from 0 to 199, that is totally 200 students have been begins. The arithmetic relational logical operation can be performed on individual member of structures but not structure variables. This is an very important. That means it can be performed on the members, not on the variables. Now I am explaining copying and comparing the structure variables. Two variables of the same structures can be copied the same way as in ordinary variables, that is assigning. That means assignments operator can be used for copying. If e1 and e2 belongs to the same type, then the following statement is valid, that is e1 equals to e2 and e2 equals to e1. That is when in mathematical we will tell that LHS is equal to RHS and RHS equal to the LHS. However, the statements
that are shown here for comparison. If E1 is less than or less than E2 and E1 not equal to E are not permitted. C language does not permit any logical operation on structure variables. We can compare two structure variables, but comparison of members of a structure can only be done individually. Student 2. See here I am showing student. It is been copied to equals to student dot marks, verifying the results of to copy opening brace. I am printing the all the results which are here. If it is 2, it will print student 2 and student 3 are equals, printf percentage d percentage s and percentage f. These are the control strings. If it is false, it will move to the else part and print student 2 and student 3 are different. Here in this case both are equal, so the output of this one is student 2 and students 3 are equal. Thank you. Now I am ending the session of 1. Next I will take the session 2.